Yes, next question. You have to read this question very carefully. Zach like to travel. He has saved 5,000 and spending money for his vacation in Australia at the end of 2015. Zach look up the exchange rate on the internet. Using the information in the table below, calculate how many Australian dollars Zach can buy from 5,000. Now, if you look at the rate here, the one for Australian dollars to rand is this one. So this means that 1 rand is equals to 0, 0,05058 rands, or that's 1 rand, or it also means that 9,518 Australian dollars rands is equals to one okay, let's start again. This one here means that the value of 1 rand is equals to 0,105058. Or if you are to go the other way, it therefore means that 9 US dollar 51 cents is equals to 0,10 rands. So as you can see, it means that our rand is very weak. Okay, then going to the doing the question now. Okay, exchange rate is quite simple. We just use simple ratio. 1 rand, it's given that it's 0,105058 Australian dollars. How much is 5,000 rands? This is what we are looking for. We shall denote it as X. Cross multiply like that. So X, the unknown, is equals to 5,000 times 0,105058. And okay, it gives you 525. In Australian dollars, 525, 29. Okay. That was just a simple rate question. Then going to the next question. Okay. Then Zach plans to take a trip to Australia at the end of 2018. Assume that the average annual rate of inflation in South Africa will be 6.10% over the next 3 years. In 2018, what amount of money will equivalent to the value of 5,000 now? We are assuming here that we are still at 2015. Now, inflation here is, we calculated in terms of compound formula. The amount after that inflation is going to be what you started with previously times 1 plus the interest rate as a decimal to the power n. If we are to do that, then it means after 3 years, the 5,000 is going to be 5,000 times 1 plus 0061 raised to the power 3 there. This should give you 5,000 times 1,061 cubed. Let's see what it is. And it's supposed to be 5,000. It's 5. It's in rands. 5, 9, 7, 1, 9, 5. Yes. Then last question there. Zach plans to invest equal amounts into a savings account on 1st December 2016 and on 1st December 2017 to have accumulated an amount of 5,980 by 1st December 2018. If this account earns interest in 9% per annum compounded annually, how much money would Jack deposit in the account on each occasion, the installment that he is going to be paying every month? Now, here we are talking about compounded amounts here. So we are still going to be using the compound formula, compounded interest formula, this one here. But now, we are going to let the installment be X. And X here is going to be our first, the money that I go put in December 2016. This is our timeline, 2016, 2017, and 2018. At this time period here, I have X amount. I go to invest it. And the formula that is going to be used is this one, if it's compounded interest. And according to the question, we are going to make two installments for the amount to reach 5,980. Okay. If we are saying the installment is X, substituting into the formula, December 2017, this amount X would have accumulated to what? 2X times 1 plus 0,09 raised to the power 1. That's 1 year. An investment for 1 year from 2016 to 2017. So it gives you this in terms of X. 1 plus 0,09 give 1.09 times X. Going to the second year, what happens with compounded interest is that now we are going to take this, the first amount, the amount for the first year, and use it here as our principal in the second period of the investment. So my principal is going to be 1,09x, not x now. I'm using the amount earned in the first year as my principal in the second year. So it's 1.09x, then times 1 plus 0.09 raised to the power 1, as you can see there. Simplifying this, we know that this is 1.09. So 1.09 times 1.09 times x gives me 1.09 squared x. This times this is 1.09 squared. You can calculate it in the calculator, 1.09 squared. Then, looking at the whole picture, the sum of these amounts that have accumulated should be at 5,980 by December 2018. So we are looking for the installment. Equate that total from the formula, 1.09x plus 1,09 squared x. These are the interest, the compounded amount first year, compounded amount second year. So I'm going to use a simple mathematical trick there. Factorizing, take out x because I see it there and there. So it's x brackets, then I'm going to have 1,09 here plus 1,09 squared. I've taken out x, factorized out x. Okay. Then, if you are saying 5980 is equals to x times 1,09 plus 1,09 squared. Then if I am looking for x, I will have to divide both sides by this. 1,09 plus 1,09 squared. Then do the same thing the other side. Cancels. Then it leaves you with x. That x is equals to 5980 divided by 109 plus 1,09 squared. When you simplify this, you're going to get an installment of 2,624,99. Yes, that's that for question 7. I'll be working on the next one from here.